talked about independent and mutually exclusive events. Okay, that was in the lesson today, but it was a small part, so I figured we could just go through that stuff and then get to this part. Okay, you're gonna want something to write, you're gonna want something to write with. Okay, we talked about yesterday, what does it mean to be independent? If you're an independent person, that means you don't need a lot of, you're unaffected by other people. You kind of do your own thing. Okay, you don't need to write that down. If it's in yellow, I would recommend writing it down. If it's in blue, my slide is blue, you don't, like, you can if you want, you don't necessarily have to. Okay, then I talked about this. You just flipped a fair coin. What does fair coin mean? Good. So it's 50-50 chance that I land on tails, 50-50 chance that I land on heads, okay? You just flipped a coin and it landed tails, okay? What do you call the next time? If you're gonna flip the coin, what are you gonna say? Heads or tails? What'd you say? Good, it doesn't matter. It's still gonna be 50-50. So even though I got tails, okay, doesn't matter that I just got tails on this next one. No. Okay, so what does that mean? That second flip is independent of what happens on the first flip. So what I get in that first flip, it does not matter. It does not affect what I'm gonna get on my second flip. So those two events are independent. The two events A and B are independent if the knowledge that one occurred does not affect the chance that the other will occur. Okay, if I want to prove that events are independent, I gotta show that one of these things is true. Okay, I gotta show that one of these equations is true. Okay, let's talk about this. If I have these two events, if I have, the first event is the first flip is tails. The second event is that the second flip is tails. Another event is that the second flip is tails. That's T sub 2. Okay, what did this say? That probability, and then it said A, and then it had that line between them, and then it said B. How did I say that as a sentence? What did that mean? What did that vertical bar mean? Given. Okay, so this says the probability of A given B just happened. Alright, so if I have the probability of the second flip being tails, given that the first flip was tails. Okay, what did I say was the probability that the second flip is tails, given that the first flip was tails? What'd you say? It's 50%, it's 1/2. Okay, what's the probability if I just flip a coin that it lands on tails? Even if I don't know what happened the first flip. 50%, 1/2. So these two are equal. So I know that they are independent. T sub 1 and T sub 2 are independent. Okay, the reason we have these equations is so that you can reason through. Sometimes you're not gonna be able to just think, oh, are they independent? You're gonna have to find out mathematically, and mathematically will help you. Okay? And what does this equation mean? This equation says the probability of A given B equals the probability of A. So the original probability of event A is equal to the probability of A given that B just occurred. So given that B just occurred, it doesn't change the probability of A. They're independent. Okay? Then you have those other two equations to help you. Alright, we talked about that. Okay, dependent. If two events are dependent, the knowledge of one event occurring does affect the chance of another event occurring.
Your head is bigger than mine. I think it is.
Okay, now this one, it says prove one is false. So to prove these are false, I gotta show that the probability of A given B is not equal to the probability of A. Not equal to, not equal to, that's what false means, I gotta show they're not equal to each other. Alright, everybody go to that slide, one more time. Okay, here we talked about, okay, if you just ordered a bunch of pizzas from Pizza Ranch. Okay, and they forgot to label them. So you ordered 3 cheese, 4 beef, and 5 pepperoni. They got them all right, but they forgot to label them. So you don't know which is which. So Jackie wants cheese, but she randomly chooses pepperoni. She wants cheese, but she chose pepperoni. Okay, you want beef. You want a beef pizza. Okay? What's the probability that you choose a beef pizza, given that Jackie just chose a pepperoni? 4 out of 11. Okay. But anybody say 4 out of 12? Okay, good. He just said she didn't put it back. So, 2 ways that this could be interpreted with replacement. If she put the pizza back, that would be with replacement. So she drew it, she didn't like what she got, so she put it back. If she didn't put it back, that would be without replacement. She did not replace what she just drew. And this is going to come up a lot. With replacement and without replacement comes up a lot in stats.
Miss Bovey, how did you get 27 on that exam? Again.
The A and B part,
Yeah.
I had to give it to you. So I had to know that ahead of time.
So how do I know that for number 10?
What does number 10 say?
It says probability of A is 1/4, probability of B is 5/6. Find the probability of A at 4.
Okay, does it say anything in the directions?
It says it's independent. Find missing probabilities.
Okay, good. So I know they're independent. So you need to know A and B, right?
Yeah.
So if they're independent, what do I know about A and B? How could I find A and B? Think about it for a little bit and then I'll come back. Okay. I've got 4 beef pizzas and there are 12 total. What's the probability of choosing beef? If I'm the first one to pick. 4 out of 12. Good. Okay. If she did replace the pizza bag, what is the probability that I choose beef? 4 out of 12. Okay. If she didn't, if she kept that pepperoni pizza, 4 out of 11. Okay. So notice here, If she put it back, my probability didn't change. If she did put it back, my probability changed. So, to add to your notes here, with replacement, if she puts it back, my two events are independent. My two selections are independent. You're gonna add that to your notes. With replacement, they're independent. Without replacement, they're dependent. So if she doesn't put it back, then what I choose depends on what she just chose. Okay, we got one more thing. Okay, mutually exclusive events. Mutually exclusive events mean they cannot occur at the same time. That means the probability of A and B happening is impossible. So the probability of A and B equals 0. Mutually exclusive events.
Actually,
They exclude each other.
Cundy, I could use some instruction.
Okay, class, tomorrow's gonna be a day where we get to continue to work and ask questions, okay? Because this is kind of tricky to get figured out, you guys are doing fine, okay? This is not due. No, okay, this is not due tomorrow, okay? Maybe try a couple just to make sure you're ready for some good questions tomorrow, but it is not due.
Alright, thanks guys. Sorry we had to go through that kind of fast.
Yeah.
And this one I did not.